So in this video, we will try to know what is the concept of borrow and why the borrow is used in binary number system subtraction. So let us say that we have two bits. So we can have four combinations of two bits 0 0, 1 0, 1 1 and 0 1. Right. So if we are subtracting 0 from 0, we will get nothing but 0. If I subtract 0 from 1, I will get 1 here. If I am subtracting 1 from 1, I will get 0. But if I am subtracting 1 from 0, then we know that this subtraction is not possible because the 0 is less than 1. So we take the borrow. So this is the borrow. The borrow is 1. Okay. So we take the borrow here, and if I take a borrow here, this will add plus 2 to 0. So this will become 0 plus 2, 2. Then we subtract 2 minus 1, 1. Right. And we have taken the borrow 1 here. So this is 1. So this is what? Borrow. Right. We have taken the borrow as 1. So we are getting the answer borrow 1 and the difference is also 1. Now, what is this value 1, 1? So, if we look at 2's complement representation of minus 1, this value is nothing but 1, 1. So, if you look at 1, 1, what is the value in 2's complement? If this number has been in 2's complement, the weight of this number will be 2 raised to the power 0. The weight of this number will be 2 raised to the power 1 and minus 2 raised to the power 1. So the value will be minus 2 raised to the power 1 into 1 plus 2 raised to the power 0 into 1. So this is what? Minus 2 plus 1, and that's what? Minus 1 in decimal number system. So whenever we are subtracting in binary number system, whatever number we are getting, the number is actually represented in 2's complement format. Right. So whatever answer I am getting 1 1 here, this answer has been in 2's complement format because the computer system uses the 2's complement representation for negative numbers. Right. Similarly, we can see another example here. If I am subtracting 5 minus, if I am subtracting 5 from 3. So how do I represent? How to represent plus 3 in binary? This is nothing but 0, 1, 1. How to represent plus 5 in binary? This is 1, 0, 1. Okay, why I have used this bit 0 here? Because I need to equalize the number of bits in both the numbers. Now, if I subtract here, since plus 3 is less than plus 5, then I need to take the borrow. Right. So when I take the borrow here, okay, now I start the subtraction from this point. 1 minus 1, this becomes 0. 1 minus 0, this becomes 1. 0 minus 1. So I need to take the borrow. So when I take the borrow, this becomes plus 2. Right. 2 plus 0, 2. 2 minus 1, 1 here. And this borrow we have taken earlier. So this is what the borrow, and this is what the difference. Right. So we know that when we are subtracting 3 minus 5, we should get minus 2. So if you check the value of this number in 2's complement format, this is nothing but the minus 2 value. Right. So you can check the value here. The weight of this is 2 raised to the power 0. The weight is 2. The weight is 4. The weight is minus 8. Okay. And the value will be minus 8 plus 4 plus 2 plus 0. And this is nothing but minus 8 plus 6. And this is nothing but minus 2 in binary. Okay, so that's why the concept of borrow is used. The concept of borrow is used so that whatever answer we are getting, it is represented in 2's complement format, because the computer system uses the 2's complement representation for the representation of numbers, for the representation of integer numbers.